In this video, we're going to talk about EZ stereoisomerism and go through different examples and how to draw them and recognize them. We're now going to move on to EZ isomerism. Remember, as I go into the diagram here, you can see cis-trans is just a part of EZ. So everything that's cis-trans can also be labeled EZ, but actually it's simpler if you've just got two groups that are on the carbons here, that you can just label them as cis-trans, because EZ is a tiny bit more complicated. But we're going to go through it, and these are very, very common, the questions that we're going to do, and we're going to give you some exam answers as well. So we've got our isomers that we've already dealt with. So we've got stereoisomers here, 1,2-dichloroethene. And remember I said that cis-trans is just a part of EZ. So we have got on here, those chlorines are on the same side. So we could call this cis, and we can call it cis there. Okay. Now, the Z in the EZ naming system stands for zusammen, it's German, and it just means together. It means on the same side. Okay. Now, that means zusammen starts with a Z. Okay, so that means if they're on the same side, okay, there'll be a Z, and we'll talk about that again, how to remember it in a minute. The next one is unabhängig, right, which is a word that means opposite, different sides, okay? And so that means that you can call trans isomers E most of the time. So most of the time, these two things go together. There are odd occasions, which we will show you, where they don't. So you can't automatically assume that Z is cis and E is trans. Okay, you have to work it out. But in this case, they are. And a simple way of remembering that most of the time it is cis, okay, and trans, or trans-E. Okay, so we've got Z and E there. So in this case, E is trans and Z is cis. But how would we decide what is E and what is Z? Okay, so even though this same side, what does that mean in reference to the same side? Because the cis-trans is just to do with having two groups on the same side. We're not talking about two of the same group when it comes to EZ. What we're talking about is something slightly different. So E is when you have the highest priority groups on different sides of the double bond. So, and I'll take you through how you determine what are the highest priority groups. So really important that you know this sentence though, the highest priority groups, because you have to, in the exam, label the highest priority groups and say they're on different sides, and that gets you your mark. Z is when the highest priority groups are on the same side of the double bond. Now, so if we look at this, and if I just tell you for now, before we go on how to identify it, these are the highest priority groups, the two chlorines. Okay, and they're the highest priority groups. So you can see here, the chlorine here and the chlorine here is on different sides. Because it's on different sides of the double bond, that means basically that we've got an E isomer. These highest priority groups, again, the chlorines, are on the same side, so we've got a Z. And like I said, in this case, E is trans and Z is cis, but it's not always the case. In the next section, we'll just go on how to determine what are the highest priority groups, so you can then talk about whether on the same or different sides. So we're now going to describe how to do the highest priority groups, how to determine what the highest priority groups are. And the really important words that you need to talk about are Cahn, Ingold, Prelog. Okay, now those are the people who determine the rules. But the reason I say you must know or recognize those names is because when you actually look at the question, it says using the Cahn, Ingold, Prelog rules, or the Ingold, Prelog rules, sometimes they shorten it. Okay, the fact is, you'll know straight away EZ isomerism. You know you don't have to do cis-trans, you've got to do EZ. Okay, so that kind of gives you an indicator, so it's really, really important. Now, the rules set down by these people were the atoms being compared are prioritized according to their atomic number. So there's lots of these rules, but we've gone over the most simple ones because they're the ones you actually need in your exam. So the higher the atomic number, the higher the priority. That's basically it. So You look at the groups on each carbon and you determine which one has the highest atomic number, and then depending on what it is, that is the higher priority. If the atoms, same atomic number but different mass number, which means they're isotopes, for example, prioritization is by mass number. So it's only by mass number if you have different isotopes, which rarely happens. The last one, if the two atoms are identical, then you move along the chain away from the stereochemical center. Now, the stereochemical center is the double bond, okay? So you move away from the double bond and you compare atom by atom until difference is found. So you go to the next highest priority element, and we'll do an example of that as well. Now, let's go through the examples here. So the most common one, and probably vast majority of times when you're doing it, you are going to just look at rule 1, and that's it. Now, if that's the case, we do it in this way. So we've got 2 isomers here, okay? And we can see that the CH3 is up and the CH3 is down. So one's up and one's down. Okay, so they're different isomers. They're stereoisomers because of restricted rotation around the double bond, but they've got differing groups around them, and one up and one down. Now, EZ is specifically used, right, either when they tell you to do so, or when you just don't have 2 groups the same. See, we don't have 2 groups the same. We don't have 2 groups the same. They're all different. So we're definitely going to do EZ. So we look at the priority and we go, right, okay, this is an oxygen. So let's assign priorities first. That is an oxygen, and that has a atomic number of 8, if you look at it on the period of time. So quickly now, go and look up all the atomic numbers of all these things. Remember, stop the video, make it active, go and look for these. Now what you actually do is this. If you want to assign it, you put a line down the middle. Now, this is what I want you to be doing in different examples as well. And then you'll go and assign the highest priorities. So you hopefully have found out that this carbon has an atomic number of 6, and this fluorine has an atomic number of 9. So the carbon, atomic number of 6, fluorine, atomic number of 9. So the highest priority one here is going to be this fluorine. So I am going to put a ring around my fluorine, okay, because that's my highest priority one on this side. Okay, so this line is really important. We're looking at it on this side. We then go to the other side of the double bond and we say, which is the highest here? Well, the atomic number of H is 1 and the atomic number of O, we go straight to the one we're bonded to. The atomic number of O is 8, or oxygen is 8. So we know our highest priority group is going to be that one there. Now, if you then look at that, can you see how they are going across the double bond? Okay. So therefore, that means my highest priority groups, and that is my list. So I would say highest priority groups. Okay, remember this is how you answer it in the exam. The highest priority groups, and you will label those highest priority groups. So you're going to say OH and F, okay? And those are on different, okay? So they're on different sides. Okay, and they're on different sides if you're putting in a full answer of the double bond. Okay, so they've got highest priority groups, OH and F, on different sides of the double bond. So I get, and that's usually 1 and 2 marks, 1 for the different sides and 1 for labelling the highest priority groups. So try and do it with this one. Okay, again, stop the video, try and do it with this one and try and write out the right answer. Now, if that's the case, okay, we know our high priority groups now. Okay, we can draw the line again to make it absolutely clear. Okay, so we look at this side, we know that this is number 1 and this is number 2, so our high priority group, this one, is that. Okay, and then we go on this one, we know the fluorine has the higher atomic number, so the fluorine has the higher atomic number, so we're going to draw a circle around the fluorine, and we can see there that they are on the same side. Okay, so they're on the same side. So if I were to do the answer to this, it would be highest priority groups, OH and F again, are on the same side of the double bond. And that's all I do, okay? And that is my answers that get you 2 marks in these exams, okay? And we'll go on to another example next. So our next group is going to use this rule number 2. So if they have the same atomic number but differ in their mass number, okay, but it's also going to use number 3 as well, because we're going to move along the edge of the chain. So first of all, stop the video. Explain to me whether this is E or Z using the highest priority groups. So if you don't know how to do it, straight away, put your line down. Okay, put your line down the middle, look towards the right, look towards the left. Okay, so our rule number 2 is going to be used here. So if you look at our rule number 2, you can see they're both oxygen. But then it goes on to H. Now this uses 3 and 2, to be fair. If the 2 atoms are identical, which the O's are identical, then move along the chain away from the stereochemical center. So basically, we're going that way, or we're going that way. And we can see the next highest priority is D and H. Now, D is deuterium. So have if your periodic table is there, you can have the hydrogen. Okay, so hydrogen, okay, is 1, 1, and then deuterium is 2, 1. Okay, so your atomic number is exactly the same, but your mass is 1 extra because this has an extra neutron. Now, if this is the case, you can actually see here D is heavier. Okay, so this is our mass number. Okay, so that mass number is heavier than H, so we're comparing them, and therefore this is going to be our highest priority group on that side. That uses 2. Now if we then look at 3, okay, if the 2 are identical, move away, and we can do this again here. And it's really simple with alkyl groups, and I'll show you how to do it. So if you look here, you go to C and C, so they're both the same. So C and C are both the same, so I can't separate those. And then the next highest priority is H. Okay, so the next highest priority is H. But the next highest priority here is C. Okay, so C has an atomic number of 6. Okay, H has an atomic number of 1. So you compare them along, so that we're comparing the C to the C, and then the H to the C. We just go along the chain. That means my highest priority group is going to be that one, because it's a higher atomic number as I've gone along the chain. Okay, so that means this one is Z, and I'm not going to name it because you don't need to name things with deuterium in for your A levels, but this is going to be both of the highest priority groups are on the same side. Remember, when you're writing it out, the highest priority groups, and you would label this, okay, so this would be C2H5. You could say that is C2H5 and OD, okay, and they are your highest priority groups, and they're on the same side. And that is how you do a Z isomer using rule 2 and rule 3. In our final example, we're going to look at this molecule here. I've deliberately done it in skeletal because you are going to be given skeletal formula and being asked to just do it straight from skeletal formula. And this is considering rule number 3. So again, if you think you can do it, please do. But I'm going to show you an easy way of doing it. So notice the double bond is not nice and flat like this. So you need to do this with your head and turn it like this, and it'll look like this, okay, and then it'll seem easier, okay. So if that is the case, I can just put my line down there like that, okay, and as you're watching the video, please put your hand like that, your head like that, it works, okay, and then all we do is we look at our highest priority groups on each side. Now I'm going to tell you a cheat method really, to be honest. When it comes to alkyl groups and things like that, okay, and you're looking across here, when it comes to EZ, not when it comes to cis-trans, when it comes to cis-trans, if you have alkyl groups of different lengths, you can still consider them the same group and then say that's cis. Okay, but for this one, when it comes to EZ, because we're doing EZ with Cahn, Ingold, Prelog rules, okay, you can then literally just go, okay, that is 1 carbon long, this is 2 carbons long. Well, the longest chain is going to be the highest priority. So instead of going through, oh, it's carbon, then it's hydrogen, and then comparative, you just say longest chain is the highest priority. That means that's the longest chain, highest priority. Okay, and this is the longest chain, highest priority. Okay, so we've got, and then if we just flip our head like this, like that, they're going across. Because they're going across, this is a beautiful E isomer. So we're going to do one final example, and this is one that comes up in questions, and it's really, really difficult, and a lot of people get it wrong. So this, if you're going for an A star, definitely this is the ones that you need to make sure you hit. Okay, so we've got a trans isomer. So cis-trans, we've got trans, and we've got cis. And if we were going to draw them as E and Z, we would say that that one would be Z and that one would be E. Remember, they don't always match, so you have to do all your working out. Okay, so which of the following molecules has the higher boiling point? Now, I've put them here. So you've got the trans has 47, whereas the cis has 60. So the higher melting point, sorry, boiling point is this one here. And why do you think that is? So let's just put the dipoles on, just to show, okay? So we should have dipoles like this. So that means the chlorine is more electronegative than the carbon, and so that makes sense, okay? So we put all our dipoles on. Now, they have dipoles, but one of them cancels and has no overall dipole. Can you think which one would have no overall dipole? Remember, if it's pulling in opposite directions, you would get that cancelling out effect. Okay, so I've kind of hinted here. So it makes sense. The trans one is the one where the dipoles cancel. So if that is the case, this one is only going to have attractive forces between each other of London forces. Okay, that's going to be the predominant force, okay, because you're going to get no overall dipole, okay, whereas this is going to be more likely to be permanent dipole. Okay, and we know that permanent dipole is stronger than London forces, and therefore you get a slightly higher melting point. But the answer in the exam is more like this. The dipoles cancel in the trans isomer, so no overall dipole. Okay, so therefore you get a slightly lower melting point because the intermolecular forces are weaker.